Hi everyone, I am Priya Jose, Assistant Professor, Department of Basic Science and Humanities, Jyoti Engineering College, Cheruthurthi. Today I will discuss about the ruby laser. Before going to the explanation of ruby laser, let us recall the basic components of a laser. For every laser, there are three components. First part, active medium. From that medium, laser light is produced. Second part, pumping mechanism. It may be optical pumping or electrical pumping. In ruby laser, optical pumping is used. This is the mechanism to achieve population inversion. The third part, optical cavity, which consists of two mirrors placed face to each other. One of the mirror is fully silvered, and the other mirror is partially silvered. The produced photons during stimulated emission are shuttling between these two mirrors large number of times, and finally the powerful laser light emerges out through the partially reflecting mirror. The construction of any laser means how these three components are arranged. Then next let us recall the working or basic principles of a laser. Working of a laser means explain the three energy transitions in every laser. First transition is stimulated absorption, that is an atom absorbs the photon and moves to the higher energy state. Next transition, spontaneous emission, an atom in the higher energy state jump back to the lower energy state by emitting a photon. Then this photon interacts with the higher energy atom, then stimulated emission takes place. So two photons are produced. This is stimulated emission and laser light is produced during stimulated emission. These three processes include the working of any laser. Now let us see the ruby laser. Ruby laser is the first successful laser fabricated by Mayman in 1960. It is a 3-level solid-state laser. 3-level laser means the energy transitions are taking place between 3 energy levels. First energy level is a ground level, second metastable state, and third level is an excited state with a short lifetime. So this is a 3-level laser system. And this is a solid-state laser because the active medium is in solid state. Then construction of a laser. Construction of a laser means how the three basic components are arranged. It has three important parts. First part, active medium. Here active medium is a ruby rod. This is the ruby rod which is taken in the form of a rod. And here ruby is a crystalline substance of aluminum oxide which is doped with 0.05% of chromium oxide. Now by doping, some of the Al3 plus ions are replaced by Cr3 plus ions. Next component, pumping mechanism. Optical pumping is used in ruby laser. For that, a xenon flash tube surrounds the ruby rod, which provides enough light to excite the atoms to the upper energy levels. Third part, resonating cavity. The end faces of the ruby rod, that is this face and this face, are polished with silvering. One end face is fully silvered. This is a fully silvered face, and the other end face is partially silvered, so that it is partially reflecting and partially transmitting. The photons produced during stimulated emission are shuttling between these two phases a large number of times, and finally the powerful light emerges out through the partially silver phase. This is the construction of ruby laser. Next, working of ruby laser. This figure shows the possible energy levels of Cr3 plus ions. In ruby laser, Cr3 plus ions are active and the other aluminium and oxygen ions are inert. So these are the energy levels of Cr3 plus ions. This is the ground state and this is metastable state where the lifetime is more, and these two are the two excited states where the lifetime is very small. Then initially here optical pumping is used, so the light flashes from the xenon flash to incident on the ground state chromium ions, and these chromium ions are excited to the levels E1 and E2. But these higher energy states are highly unstable. So, the chromium ions make downward transitions to the metastable state. These are non-radiative transitions. And this is the metastable state where the population inversion is achieved. Then, a spontaneous photon emitted by Cr3 plus ions at metastable state initiates the stimulated emission. The spontaneous photon interacts with the higher energy ion, and during stimulated emission, laser light is produced. The wavelength of the laser light is equal to 6943 angstrom, which is red in color. And these produced photons are shuttling between the two polished phases a large number of times, and finally the powerful laser beam emerging out through the partially silvered phase. This is the working of ruby laser. Then advantages: it is easy to construct, long lifetime, strong intense beam of laser. Disadvantages: first disadvantage, it requires cooling system to avoid any damage of ruby rod due to excess heating. The output of this laser is not a continuous laser beam. The output is in the form of light pulses. This is because the xenon flash tube, which surrounds the ruby rod, is operated in the pulsed mode. So the output is also in the form of light pulses. Applications: used to study about matter, quality of matter, fusion, nuclear bombs, etc. Used to remove tattoos and also skin lesions resulting from excess melanin. In military, it is used as range finders and laser weapons. Used in spectroscopy and holography and for laser entertainments. It's used for surgery, general diagnosis, cutting, drilling, building of very hard materials. Thank you.